Hello, this is a contemporary topic review on metering and measuring in microfluidics. This video will give a quick summary of what this is used for, as well as detailing a few of the different methods used to accomplish metering and measuring in microfluidics. So first of all, let's look at the applications, which are multifarious. Pretty much any field you can imagine, microfluidics are applicable, and therefore the metering and measuring of fluid flow in microfluidics are also applicable. So at this point we'll move on and look at some of the methods with which we accomplish this. First off, and most simply, is the direct pressure method. Here we have an externally applied pressure to the fluid flowing through a channel. And we have a known channel geometry, known fluid properties, and so we can get the mass flow rate as an output of a function of the fluid, those properties, and the geometry. One step up from this is the actuated membrane. Now, the actuated membrane uses two channels, one on top of the other, and the top channel is known as the control channel because as pressure is applied to the fluid traveling through it, it actually balloons out and closes off the flow channel. So as you have a periodic pressure, what happens is at the peak pressure, the control channel closes the flow channel and you get the little globules or bubbles as shown in the images to the right. One step up from this is the peristaltic pump. It's basically it's several actuated membranes in a row, and this is actually able to control the rate of continuous pumping of a fluid, much the same way your esophagus controls swallowing of food or water. Basically, they flex one of these control channels in sequence, and the rate at which these are flexing affects the mass flow rate of the fluid. Moving on from pressure-based flow control, we have mechanical movement. This one's an electrically driven example. You have an electroactive hydrogel in the middle of the channel with two electrodes on either side, and as polarities are applied to the electrodes, the hydrogel kind of flicks to one side or the other, depending on the charge. So you open and or close one channel or the other. In terms of filtering, probably the simplest way to filter things is just through channel size. The example here is given of blood. We want to separate the plasma from the rest of the blood, and so plasma is much smaller than red blood cells. So several micro channels were fabricated to allow the plasma to pass through from the main channel on the left to the main channel on the right, whereas the rest of the blood material just continues on its merry way, and this would most likely be pressure driven. We have magnetic pumping, which is a combination of a peristaltic pump and the electromechanical metering. Basically, you have a rotating disc that passes over a stationary magnet, and the PDMS membrane has magnetic material impregnated into it. And as this material passes over the stationary magnet, it's pulled down and then released, and it creates fluid flow much in the same way as a human heartbeat might. And finally, we have simulated gravity, or centrifugal force. And so as we've got a rotating disk, there's a force experienced by particles on this disk, r omega squared, where omega is the rotational velocity. And so what you can do is you can alter your omega to control how quickly or slowly fluid separates and travels toward the outside of this disk, thereby metering the flow. Here are our references, and that is about all. Thank you.